uh, can you hear me now? Hopefully. My microphone is on now. If not, I might have to just can the stream and start again. So good. Yeah, I guess I don't know. I guess I should say in chat. Okay, you can hear me now. Okay, nice. Sweet. Yeah, okay, so G's a finite cyclic group. By the way, Demodomus, thanks for joining us. I don't think I've seen you around here before. Probably because I'm normally streaming in the mornings. So when the cohomology groups are finite, we define the Herbrand quotient to be this. Why though? This seems like such a specific thing. We define it specifically for finite cyclic groups. Okay, I'm just gonna go with him on this. If we have an exact sequence, then we have this multiplicative property. Proof, we can truncate the very long exact sequence as follows. Right, I think this is something we just proved for finite cyclic groups recently, right? We did the finite cyclic group stuff. Yeah. No, those are some specific examples. Where was the section on finite cyclic groups? Cyclic group of finite order, then every second group is isomorphic. Sure. But so why would we get to here? Oh, I see. Because we're taking K prime to be the kernel of this. Okay, so we're just cutting it off by does that make sense actually? Yeah, I guess we can always do that. I guess we can do that. And then sure, we should have this property. Sure. Oh, he even does a nice little proof for us. Okay. That's nice. So if M is a finite module, then M is equal to 1. Huh. So why are these sequences exact? I see why the first one's exact. I mean, this is basically like, kind of from the definition of M sub G, but why is the second one exact? I guess this is, I guess from the first, should we get a long sequence in cohomology? I mean, we take cohomology, we apply it to a short exact sequence, we get the long one. But then, yeah. Wow, no one's else turning up in chat. It's because they're too used to being yapping during the mornings. Oh well, secret bonus episode, I guess. Or this isn't a bonus episode; it's a regular episode, but. So this should be true for any generator of G. Yeah, but then why does the norm map come in here? I'm very confused by this. From the first statement, we find that these two have the same order, which is wild. What? That's kind of a crazy thing, right? That's sort of unexpected, in my opinion. And then in the second, it turns out that those two groups have the same order. I see. You got any book/reading material suggestion to start learning category theory? Yeah, definitely Tom Leinster, Basic Category Theory on Archive. Yeah. Some students at my university did a reading group with this over the summer, and yeah, I think it's nice. I mean, 191 pages. Yeah, the book's not even that long. Well, I mean, it is, but like, I don't know. There are some sections that are, like, I think we kind of skipped over the set theory section a little bit. It is a very late stream indeed, Lucian. It's not going to be a regular thing. It's just because I was too busy in the morning. But yeah, what to say? I mean, it's got all the basic stuff. It's got all the basic stuff that you need in here and more. Yeah, and so we made it through this book. I mean, not everyone made it through the book, right? Reading groups always fall apart, but you know, we made it through. Algebra Chapter 0 has a good preface with category theory as it pertains to algebra. That's true. Yeah, basic stuff. I mean, I would say I wouldn't recommend it as an introduction to category theory necessarily. I'd recommend it as a book that you study throughout your undergrad and even into grad school on algebra, because it introduces categorical concepts slowly. But you know, sometimes you need a source that has, you know, all these definitions together, you know, functors, natural transformations, adjoints, Yoneda lemma, limits. You know, it's just nice to have these things, the whack of these things in one place. Okay, but I'm confused. I'm confused about this proposition. I'm confused about this proposition. Like, is he just saying, is this supposed to always be an exact sequence? Yeah, good evening, Ken. Good evening. Glad to see you here. Yeah, maybe I should just sit down and work out why is this. I don't understand why this bottom one's an exact sequence. I guess, what even are these maps? I'm not even sure what these maps are, right? Why does h minus 1 of m inject into m sub g? What was ht minus 1? That was the kernel of the normalizer modulo the image of this for a finite cyclic group. So the kernel of the normalizer modulo the image of that thing. But then injecting into... Oh, right, because m sub g is we're modding out by that. I see. Okay. Yes, okay. I see. Maybe I should explain it for you guys, if anyone's following along. Because this is basically... right? Unless I'm being crazy, like mg is like m modulo this thing modulo the image of this, basically, the space generated by the image. So of course the kernel of the norm map, which sits in M, of course the quotient of the kernel by this thing then includes in here. And then that makes sense that gets killed. We can see, right? Then we're applying the norm map. Sure. Okay, I believe it. I know. Maybe, I mean, if you guys don't believe it, yell at me. But I believe it. So I'm happy to keep moving forward. Okay, so let alpha be a homomorphism of G modules with a finite kernel and co-kernel if either HM or HN is defined. So that means, what does it mean to say that they're defined? That both of the cohomology groups are finite? Because I could define infinity over a finite number to be infinity. Or we could even start doing cardinal arithmetic. But I'm assuming he means that they're both finite. Suppose that then the other one is finite. Okay. Well, maybe it'll come clear as we read the proof. Suppose Hn is defined and consider the exact sequences alpha m. Okay, yeah, that makes sense. From the first sequence, we find wait, what? Yeah, Sergio Polar Bear. Hopefully, I'm not messing up everyone's sleep schedules, because your bodies are used to like seeing me in the morning. So now you're gonna wake up and think it's time to wake up. Right. I see. I guess right. This is from the proposition, from the multiplicativity of Herbrand quotients. Right. So we have the multiplicativity. And we also have the what am I doing here? We also have the result about equaling 1 for finite modules. And right, we have the finiteness. Well, we have the finiteness assumption on the co-kernel. So right, so this should, and then we're assuming Hn is defined. Okay, yeah, so it should be defined and equal to that. Okay, and that's similar for AM. Not bad. We're making progress today. Tate's theorem. Okay, let me just scroll past this. I want to get a sense of where we're going to. Oh, it's theorem 311. Okay, that's probably where we'll end when we get to 311 today. We'll see. For the remainder of this section, all cohomology groups will be the Tate groups. And so we drop the T except in the main statements. Okay. If G is a finite group, let M be a G module. If H1M is equal to 0 and H2 of AM is equal to 0. Oh, okay, interesting. If both of these are equal to 0 for all subgroups, then all of the Tate cohomology groups. Wait, what denote drop the subscript except in the main statement. So is this the main statement? And this is supposed to, this is H without the T, and I get confused. The cohomology or the negative ones? I always forget. If G is cyclic, this follows from the periodicity of the cohomology. Yes, I agree. Assume now G is solvable. Interesting. We shall prove the theorem in this case by induction on the order of G. Because G is solvable, it contains a proper normal subgroup such that G mod H is cyclic. Because H has order less than that of G. You like algebra and topology, but your analysis is very weak. Does anyone have a recommendation for self-studying analysis? You like a Luffy for algebra, for context. That's a good question. I don't know if I have a good answer for you. Though, like, I don't know what's analysis's answer to a Luffy's book on algebra. I mean, certainly there's better places to learn analysis from than Rudin, but, like, there's nothing in this world that will do you good like gritting your teeth and making it through Rudin. So, I don't know. If G is cyclic, yeah, where are we here? Okay, because H has order less than G, the pair satisfies the hypothesis of the theorem. Yeah, so therefore, we have exact sequences, which we'd previously computed, given by this. So we have these two assumptions, and we know that these are 0 just by, well, because G mod H is cyclic. And this implies, right, G mod H is cyclic, so all of these are 0. And therefore, the sequences in star show that this is 0 for all R. Right, because we know that this is 0. And right, because of the periodic, because both of these are 0 in the periodicness. Okay. We next show. You were hoping I wouldn't say that. Guess there's no escaping the truth. Yeah. I mean, look, if you're not enjoying the book, then find something else, Tao's book on analysis or something. Yeah. Or there's, like, these books that are, like, visual introduction. I can't remember the name, but there's some book that's, like, a visual introduction to real analysis or something like this, and it's, I've seen it in person, and I just flipped through the pages, and I thought, oh, that looks like a nice book, but, yeah. Next we show, I guess we haven't shown it 0, that H0 is 0. So let M be a fixed, or let X be a fixed point of M. Because H0 of this is 0, there exists a Y in here, which is in the image, such that the norm map is X. What? I'm tired. Because Sammy Zhang, I'm your goat. I was about to baa like a sheep, but that's not really goat noise. But I guess goats kind of make that noise too, right? Maybe I should get horns. So there exists an M, because this is 0. I mean, H0 is the G mod H of the H fixed points here. Should be the G mod H fixed points. Yeah. Okay, let's try and work this out. H0 G mod H of MH is 0, but this really means that this is, I mean, what is this really? It's the H fixed points of M, and then we take the G mod H fixed points of that, right? So, if that is 0, then, so the claim is what? Let's see exactly how it's written. X is in MG. There exists a Y in MH such that the norm of G mod H X is equal to Y. No, Y is equal to X. Yeah, Y is equal to X. Aye. These paper reviews on YouTube are fun to watch. It's helping you get better at proofs. I should do more proof reviews of viewer submitted proofs. So I need more viewers to submit proofs. That's your cue to submit me proofs for review, by the way. Null space. You were not expecting to see a live video for Galois Cohomology right after looking for class field theory. Well, it's all connected, man. The world's things are happening at the right time sometimes. Glad you love the content. Hello, Noel. Okay. Why is this true? So X is fixed by G. Why would this be true? Well, I'm going to work backwards from the statement, and I'm going to compute, if this is true, so X should be equal to norm G mod H of Y, which is what the sum over, G dot to mean cosets of G dot Y, I guess, is maybe a weird way to write it. I guess I could say something like I equals 1 to n of gi dot y, where these are the distinct coset representatives. Can you submit a paper? You need some feedback on your equations. You're a physics student, so you're trying to see how accurate your math was. Oh, did you recently leave a comment asking about that? Sorry, I didn't reply to that comment yet, but if you're the same person. You can definitely although you should watch my other video. I call the series Your Proofs Are Trash, and the idea is I'm supposed to roast the proofs. Well, in those ones I don't end up roasting them too hard, I don't think. But just be advised, what you might be getting yourself into. In the wake of some comments of my video where I'm making fun of crackpots, I started thinking that maybe it's better if I stick to sort of roasting proof submissions from consenting people. Although I don't know, maybe this will be the video tomorrow. Depends on I might have to do some audio, some editing for my interview with I did with Silverman today. So I don't know which video is going to take less time for me to make, but I'm going to ponder about the morality of my crackpot videos. But anywho, yes, all of that to say, you can submit something to my email, ktheorytutoring@gmail.com. It's in the link of the description of most of my videos, hopefully. Let me know if you find a video that's not the case for. So, yeah. And, of course, if you do submit it, I mean, maybe now that people are seeing it on live stream and they see some physics stuff, they might be like, oh, I think that's the person with that username. But I do keep them anonymous as well. So, yeah, if that helps. Yeah. Okay, so where was I here? So, yeah. So this y is fixed by everything in H, and well, I'm trying to figure out what element this y should be. So for each x in G, x is fixed by all of G. Yeah, is there something obvious from the definition that I'm just missing? So it should be the image of this map. I mean, couldn't I take y? Couldn't I just take y to be x over g, over the order of over the order of g mod h? Because then the g's fix the x, so I would just end up getting g mod h times that. So is that all it is? You make a submission right now, and by the way, you can take the heat. Excellent. Just want to get better. If your stuff is ass, don't hold back. Okay, cool. So yeah, my only one other warning is that it may take a little bit of time for that episode to come out. I'm working on some other things, and I have them that I'm planning. But then again, maybe not, because I might need to make some content on the fly if certain things get delayed. But absolutely it will happen. And maybe even I'll give you some pointers between that. No absolute promises, but yeah, hopefully you submitting this will kick off more people submitting, and then we'll get a new Your Proofs Are Trash episode sometime soon. Okay, so we're almost at 9. Wow, I don't think I'm tired. I don't think we're gonna make it to the end of this proof today. But let's see, where were we here? Solvable pair, boom. We were here. And because h naught m is equal to 0, I think that was part of our induction hypothesis, there exists an m in here such that this. Okay. I don't feel like I need to investigate that. I will just write that down. Oh, wait a second. Wait, I didn't even use this. Wait, I didn't even use the fact it was 0. Hang on. I didn't even use the fact that this was 0. What? Wait a second. Yeah, wait a second. What does this say? This says that this says that the only vector, or the only element fixed by all of G mod H is the 0 element. Yeah, now I'm really confused. So whatever I just said here was nonsense. Oh, sorry. Okay, I see. Never mind. This still works, right? I forgot I was working backwards from here. So my suspicion is that I could take for this y to be here, but then I would need to know that y is an element of y is an h fixed element of M, but of course it is. Of course it is, because it's built out of X. Yeah, this is why I shouldn't be streaming at this time of night. But yeah, I still didn't use. Wait a second. I still didn't use that fact. Oh, gang. This has been a messy episode. This has been a real messy episode. Okay. I think I'm gonna leave it here. It's been too much of a mess. But thanks for joining me anyways. Hopefully tomorrow morning we'll be back to our regularly scheduled programming, and we'll see how that goes. So, until then, QED.